Whenever you ask an AI model something, you expect to gain from it information, facts, ideas, etc. In return, the model gives you an answer. It will be correct, facts checked, and with problems being solved. But if you are someone who is using it often, you might have noticed something strange happening with the model. It sounds completely confident on a response that is totally wrong. What we are witnessing here is called AI hallucination. Hallucination in AI happens when the model generates an answer that sounds plausible but isn't true or doesn't exist. Here's an example. Let's say someone asked an AI the simple question: I need to wash my car. The car wash is 100 meters away. Should I walk there or drive? The model then answers walking as the better choice. The actual answer obviously is to drive the car. I mean, you can't wash the car if you don't drive it to the car wash. So this is one type of hallucination where AI lacks the situational logic. There are many more. If you ask AI to count the number of words or letters or ask about any information that is new, it often fails to produce the right answer. But the irony part is that how it gives these wrong answers with such confidence. And this totally begs a question. Why are they behaving like this? To understand, we must know how the underlying model works. Today's AI, what we are using, is technically called a large language model, a system that learns statistical pattern from an enormous amount of text. Their goal is to predict the most likely next word in a sentence, where we train them using two methods, pre-training and post-training. In pre-training, what we do is collect nearly all text data from the internet and clean the noisy parts for these models to learn. The text in the data is split into chunks called tokens, then converted into IDs and gets mapped into high-dimensional vector embeddings. These embeddings are then fed into the model's neural network, its brain, where multiple layers with attention mechanisms use context to capture meaning, grammar, and patterns. At each step, the model processes these representations with a single core objective: predict the next word that has the highest probability. To train them efficiently, we use a method called teacher forcing, where we always feed the correct previous tokens or correct previous data to predict the next one. At each step, it predicts the next token, compares with true answer using a loss function, and updates the fix using backpropagation. These methods are all just statistical mechanisms in service of that one objective. Now, this teacher forcing quietly plants the seed for hallucination. Think of it like a student who only ever practices with an answer key in front of them. They get very good at producing correct answers, but only when everything around them is already correct. The moment they have to work from their own previous answers, they are in this unfamiliar territory. This is called exposure bias. The model gets trained in perfect conditions but fails to operate in imperfect ones. For example, let's say the input is the capital of Australia and the correct next token in the training data is Canberra. So during training, the model learns to assign a high probability to Canberra given this context. But in real use, the model generates one token at a time, using its own previous outputs. At this step, instead of selecting Canberra, it might assign a slightly higher probability to Sydney due to its strong association with Australia. So it generates as the capital of Australia is Sydney. Now this becomes the new context. The model was never trained on this incorrect prefix, but it treats it as valid and continues to write confidently. This is how hallucination gets formed. Other factors also contribute to AI hallucinations, particularly when the model lacks sufficient knowledge or when the training data itself is noisy. But underneath all of it, their design itself was made to produce on what sounds right, not what's actually true. Pre-training has no answer for this, and that's where the post-training comes in. The post-training of LLM is done to ensure that the model aligns with us being helpful, honest, and less likely to produce hallucinations. The most powerful method used to reduce hallucination is reinforcement learning from human feedback or RLHF. It happens in 3 stages. At first, we fine-tune the pre-trained model with carefully curated human-verified prompt and response pairs. This gives the model a strong starting point. At second, we train a separate model called a reward model that judges the response in a way humans would. Human raters rank multiple responses to the same prompt, which is clearer, more honest, and more helpful. The reward model gradually learns from thousands of these judgments, developing a sense of what a good response feels like. To be precise, reward model doesn't discover the truth. It just reinforces what the pre-trained model already kind of knows. And this totally depends on the quality of data we use in pre-training and post-training. Getting back to our example, the capital of Australia is Sydney. The reward model doesn't fact-check for Canberra to be capital, but judges multiple responses in a way human raters would do. which eventually lead to giving Canberra as the capital of Australia. At the final stage of RLHF, the weights get updated based on higher scored responses, which keeps it stable during inference. A recent study from OpenAI suggests that reinforcement learning itself contributes to hallucinations. During training, neutral responses like "I don't know" are often penalized similarly to incorrect answers. Companies design reward models this way to perform better on benchmarks and user expectations, where attempting an answer is often preferred over leaving it blank. This leads to incorrect confident responses. To fix this, the study proposed assigning no penalty for neutral responses, encouraging the model to admit uncertainty instead of guessing. Beyond RLHF, a method called RAG gives the model access to external resources at inference time, so it retrieves facts rather than guessing from memory. Instead of a faster response, allowing the model to reason step by step gives some strength to catch its errors. Also, tools like Code Interpreter, Calculator helps in reducing these errors too. As a user, you can also reduce hallucination in your chat session by providing a well-curated prompt. In the end, eliminating AI hallucination entirely remains unsolved with current architectures. We continue to find better ways to reduce it, but a complete elimination isn't feasible until a new approach to AI is developed. If you enjoyed watching this video, hit the like and subscribe button, and if you have any thoughts on these AI hallucinations, leave it on the comment section. Thanks for watching.